My name's Patrick Williams. I'm from StorageOS, and we are a startup. We provide persistent storage for containers, which is why we're partnering with Docker tonight. Farhan is one of our senior PREs, and he's going to talk about the way that we work, how we fit into our ecosystem, and the technical architecture behind StorageOS. I'm going to talk a bit about our purpose and our partners. Farhan's then going to do, if he's got time, potentially before the beta, he's then going to do a demo, so live demo on StorageOS, on Docker EE, and yeah, so that's what we're going to do. Who has heard of StorageOS? A couple of people, that's fine. We are a startup, as I say, went GA in November last year, and we have a few clients on board now. Our core purpose is to help companies like Sainsbury's and developers within those companies put and run their stateful applications on containers. So up until now it's been stateless applications, and everyone thinks containers are great for those, but stateful applications are hard because of the storage factor. So we help you liberate containers and the storage within, and give you total control of your storage. The way that we do this is, Farhan's going to go into more detail, but I'm going to give you a few examples. So if you're talking to developers who are on the cloud and want to self-service provision, then we can offer you complete native Kubernetes integration. If you're talking about an automated data policy, then we give you a rules engine to automate placement of your data and apply policy. If you're talking about reducing storage usage and network bandwidth consumption, because that can be a real pain, especially the cost for that, then we'll give you in-memory caching and compression. And if you want to decrease your infrastructure costs, then we provide replication HA and synchronous replication, which means that you don't have to pay for that expensive SQL or Oracle license. And lastly, minimizing overhead, reducing latency, because we offer a locality service that is being built as we speak, and Farhan might go into that later. And finally, you can use any platform. So you can use on-prem, you can use any cloud. We integrate with all of them, and you don't have to choose which cloud. So our partner ecosystem looks a bit like this. These are the stateful applications that we've tried and tested on. As I said at the bottom, any cloud service we work with, including the big three, so AKS, EKS, and GKE are the managed cloud platforms. So if you're using native Kubernetes and you don't want the managed service from one of the cloud platforms, you can just go native Kubernetes. But if you want to manage more of the platform, then you'll choose that, which is a great thing to do. There's a couple of more, so orchestrate, in terms of who we work with, Openshift and Rancher are the biggest two. Heptio are coming along, and you can tell that market is really massive because VMware bought Heptio and IBM bought Red Hat. So it's just everyone's trying to get into that model now. And I just want to see a show of hands in the audience who is using Kubernetes in production already. That's going to be fun. Okay. That's pretty good. So that's actually the end of my bit, because there's a few beers over there. Farhan is now going to talk about, so So you guys are fairly technical. We want to, we talk to developers at the same level, and we want to be able to show you that there's another way to do storage when you're using Docker. So now I'm going to pass it over to Farhan and...
Hello. So my name is Farhan. I'm an engineer at StorageOS, as Patrick mentioned. I'm going to talk about StorageOS and what it does, the solution that we provide, but before I'm going to start talking a bit about the ecosystem that is currently available for storage for containers. So there are solutions out there, mainly solutions that have come from traditional environments and have evolved to container or tried to glue into containers. And once we understand the problems we're facing with these environments that you probably already have, you already have these pains, I'm going to move a bit onto why we built StorageOS, how we built it, and the principles applying behind it. So StorageOS has been designed and built by operators, so from DevOps engineers or software developers for software developers. And this is why I'm going to go super technical all along, and if I have time, I'll do a live demo, and I'm going to go to the concept of live demos. So first of all, if you have a Kubernetes cluster, usually the most obvious thing you're going to start using when you want to use storage is, I have an application, I want to save some data, I want to survive the restart of the application. So what usually you do is you start a host tier application, which basically means I put my application, and in the host where the container is running, I have a segment of the file system that is associated to that container. This is easy, this is very simple, you start there, things start working fine, but you eventually will see that you deploy, for instance, a Postgres application, some chunk of the disk in that available node or the underlying host have data, but what happens as soon as you lose a node is your data is gone. It's that simple. It's a simple solution, but that happens. Unless you start having replication at the application level, so in this case at the Postgres level, or the Elasticsearch level, or any kind of big enterprise solutions, you can encounter this really early on. So this is a solution that is maybe for development, usually not very resilient. So really early on, we're going to have service failure, difficult to recover, data loss, something we cannot afford, for instance, as a continuity service operators or DevOps or the way you want to call it in your organization. So the second model, which most of the application and enterprises have gone to, is centralized data. Centralized file system, centralized block storage, meaning I put some data into what we call a few storage servers, and then we have some compute nodes that deploy what we call stateless applications, but in this case we're going to be also stateful applications, and we mount through network. Right? And this is how Ceph works, this is how Gluster works, this is how traditionally NFS has worked. So what we've seen in some people, mainly Red Hat, and putting a lot of effort is, let's transform some of these tools that we already have into a containerized world. What happens is, this defies the whole purpose of the containers. What we want is lightweight things that move around fast, spin up fast. That if we have a problem, we can spin up a new one, anywhere else, that's fine. But what happens is that those storage nodes start having a lot of trouble. They're big, they're heavy, no one wants to touch them, no one wants to upgrade them, because if something happens to them, a lot of bad things happen. So in the end, we end up having some issues around it. And they have many great things, don't get me wrong. But we end up trading things like bottlenecking the network, bottlenecking the I/O, latencies on input-output performance. They're usually very stateful, they don't move, they don't scale well. So we start trading all these problems to have one thing and one thing only, is that we have high availability in applications. So if at least the node in the compute area goes down, at least we can remount that data. High availability is time to recover, it's a decent time to recover, but we also keep trading all that complexity and all those problems and money because of that. So when we start losing nodes, either in the compute area or in the storage area, we start having really, really big problems. We have things like node failures, compute node failures, vertical network partitions, horizontal network partitions. What does that mean? What happens if the network between these nodes and these nodes goes down? Data is not available. How applications retry and input-output operations on file systems that are mounted remotely. NFS can remount sometimes, but other applications like Cluster, for instance, struggles if you use SCSI. So you need a huge amount of knowledge on how your things or how your systems work internally, at the kernel level almost, to ensure high availability. And that is a pain. So when we have all these problems again, we end up trading these for application failover. That's what we want. The application can move, kind of. Thanks orchestrators such as Kubernetes, we can start the application somewhere else fast. That's great, that's fantastic. But the stateful problem is still there. So in the end, what we have done for the last 10 years is moving applications, or stateful applications, or monolithic applications into stateless applications. What we have done in the end is we delegated the problem. We made our applications stateless, which is great. They are very flexible, and we can scale the applications really well. But we have delegated the stateful problem. In the end, those applications need to save state somewhere. And that is what we're trying to solve here. So, have seen the state of a bit of the world, how it is. Do you have any questions? You have used NFS or Rook or Ceph any time before? Have some experience into it? Anyone? Hands up, anyone has tried to do some persistent storage on containers? Why you haven't? Why haven't you? Because maybe you've been told that you can't. Or maybe you've been told that it's not good, or maybe you've been told that it's a problem. Stateless application, we move that, we put maybe our databases to RDS, or we keep moving into a hybrid mode where our containers have stateless applications, our databases keep working on the old high available virtual IP 2-server load balanced HA system, which defies the purpose of the whole thing of trying to be more agile, more cloud native. So, being understood this, and I'm only 13 minutes on, being understood this, we built StorageOS to come to solve the agility problem and to come to solve how and when and where you deploy your data. So, first of all, the 6 common problems when considering storage for containers. I mentioned a few of them, but let me put them in a bit more structured way. If you cannot read, let me go through it a bit. Stateful workloads with HA are part of any architecture. Storage is not portable and locks applications into data center or cloud provider. Think of EBS, think of SanDisks, think of any cabins, tapes, etc. This usually constitutes a problem, and this is an infrastructure problem, not an application problem, until how we have seen that today. So we usually have a lack of APIs, and the orchestrator container integration limits automation and a dynamic provision. What does that mean? I want more disk, I have to call someone, come and plug 3 terabytes of disk into my nodes, or I go to Amazon, give me 3 more EBSs, it's fast enough, but in the end it's a block storage, plug it there. It's not very well API-based design. Maybe EBS have been in the provisioning level, but it stops there. So we have rigid topology and deployments, means that applications have to be developed around the storage. So you're architecting your applications because how the storage has been architected, and not because how the application should run. And this has been for a few years a problem, because we are restricted in the way we are building these applications. So then we end up having functionality or features such encryption, or encryption, how we save the keys, etc., that also are usually very entangled to the provider you use. You use some Some EBS, for instance, encrypted volumes. The keys are in AWS, or you can use your own solutions, but then you always have a third party in the middle, so there is a difficulty as well to add functionality to the storage solutions. And in the end, we have, you have to pay a lot of money in advance to have disk, usually. Or if you want something that performs fast, you have to pay in advance. If you go to cloud environments, yeah, you can have cloud disks, and in the end, to have something that goes beyond 3,000 IOPS tends to be expensive. So when we say that must evolve, it means that taking these problems into consideration and what we have seen before, we have to build something that tries to solve this problem. So I'm not going to keep going around again. So when we build StorageOS, we build thinking on 8 principles. First, application-centric. If you think of how Kubernetes provisions storage, you can think of the application-centric as I want my database to ask for storage, not my operators to provision storage and tell MySQL or Postgres that you have storage. So we want to do something that is kind of declarative, that you can ask storage under demand. Maybe you want a pool of data available or chunks of disks available that I can query. But this query has to be automated. It has to be from the application point of view. So we are moving on the stack of abstraction where the disk has to live. More than till now, I would say that nowadays still we have the problem that storage is something that operators provision and build, and then we give that to the applications. In the second place, we want to be platform agnostic. Doesn't matter if you run in hybrid environments, in a cloud environment, in an on-prem environment, in EBS mounted, with SanDisk mounted, with Google Cloud Volumes. We want to be agnostic to that, and actually all the layer that StorageOS gives is agnostic to that. We want to be declarative and composable, because Kubernetes has proven that actually this is quite config. It comes with some problems to be YAML-based, but it comes with a great way of defining the things you want. Many people is a bit reluctant still because of, it's a bit reluctant, but at least if we know what we want to define, we can reproduce this in test environments, in staging environments, and we can reproduce that into production environments without changing how we operators do things, how we plug disks, how we provision disks. It's exactly the same. And how is that possible? Well, this is possible because we are API-driven managed. That means I'm talking to an API, let's say I'm Kubernetes, and I'm talking to an API, give me the storage. Provision 10 gigs of data. Give me storage that has an application. These are API-based applications. This is taking what we think as a storage as a service that is consumable by your other parts of the infrastructure. We need to be agile, that's obvious, but actually, even if it's obvious, not much work has been done on that. Why? As I said before, the models that are centralized usually are very big and don't move much, but hey, we want autoscaling groups. We want to pay for what we use. We want all this stuff that are great on stateless applications also in stateful. Of course, it's going to be more difficult because you have data. Moving 3 terabytes of data from one list to another is not going to be fast, it's not going to be easy. But we have to be able to be agile, to move on, to scale up, for instance. Maybe scale down is difficult because we have to move data around, but scale up has to be something that happens real fast. Don't worry too much about reading these, I can share that stuff, so I'm going through the main points here, but I know a lot of you are reading and maybe it's a bit too small, so I'm sorry for that. But anyway, it has to be secure, no doubt. So what we have implemented StorageOS is a model following the Kubernetes model of role-based applications, and we seamlessly interact with it. For instance, every time I provision a StorageOS volume in a Kubernetes namespace, that namespace is created in the StorageOS world, and all the resources you can do, all the things you can do from a namespace point of view on Kubernetes can only be done on StorageOS. We have segmentation of concerns, we have segmentation of where the data live, we have implementation on who can do what and who can access where, and of course things like address encryption can benefit a lot of people. That requires that data is not accessible when it's written to disk or when it has to be destroyed. We don't just have to be destroyed. You just have to destroy the keys of an encrypted volume to consider legally that actually the data is not accessible or is being destroyed. So for many people, this can also be a problem. This is for granted, it has to be performant. If I have to go through a network every single time I do an input-output operation, database is not going to move very well. So that's for granted, but actually, if we want to trade high availability, we usually trade performance. So with StorageOS, we're trying to be agile in the way we implement the architecture, just also to have high performance and low latency. And finally, it has to be consistently available, meaning whatever you write is there. That sounds very, very obvious, but if you think how our systems work in the world, we have caches at the right, where we write into disks. We have usually batteries in the writes, and we have software writes, we have caches in the file system, we have caches in the operative system, we have caches in the devices, we have caches if you use something a bit more fancy than a normal hard disk. So in the end, the fact that things are consistent is taken for granted, but is not that easy from the operative point of view. So this is fundamental. So what StorageOS is, and now yes, you can do it. StorageOS is a software-defined storage platform for running enterprise containerized applications in production. How does that look like? Well, first, what are we solving? We're solving the issues I just mentioned, so I'm going to go very brief here because I already mentioned that. But we have functionality for replication on the fly with synchronous replication, which means that every single byte of data written into one place is written into a second place before actually that write is acknowledged. We're platform agnostic. We can scale horizontally in an automated fashion without interaction from the operation still. We integrate seamlessly with Kubernetes or any distribution you want to call of Kubernetes and Openshift, also in different clouds. We integrate with Docker very well, with Rancher very well, with EKS very well. So in the end, anything that is a Kubernetes style model, we integrate. How StorageOS looks like. And this can be a bit confusing, but let me go through it. StorageOS is deployed as a container. So we implemented this piece of software that has two components. One, a storage engine, and two, a control plane. So we could say the legs and the brain. The storage engine could be a full engine where we get writes and we decide where we write these into disks, which disk are we using. Things like, for instance, encryption or quality of service, checksums, where the data lives, in memory caching, things like that are in the data plane, which is the storage engine, and then we have the brain, which is the control plane. The control plane exposes an API, for instance, for Kubernetes to talk. The control plane decides, for instance, I have a pod that is in that node, maybe I should put the data next to that pod. Or it talks to Kubernetes and say, well, your stateful application, your stateful set is not starting because the node is partitioned. Maybe you should shoot that pod and start it somewhere else and fail over to StorageOS replica to start this in less than a minute, which means that you have high availability without paying active-passive infrastructure. If you have any doubts here, I can go in more detail, I think, for the faces. I can keep going. So where StorageOS runs in here, as I said, is a container. How do we do this? So well, in a traditional environment, we have hardware, host operative system, and application. We move to VMs, where we add a layer, and we add a second layer of the containerized world. We add a Kubernetes or different kind of orchestrator in the middle. We put StorageOS as a container in every node of that platform. And I'm going to show some architectural principles later because not necessarily every node. And then on top of that, we put the application containers. And that means that application containers mount a Linux file system, a normal file system, that is backed up by StorageOS. So, we have a few nodes. These few nodes install StorageOS container in every one of them. When this happens and we bootstrap the application self-discovers itself and through a gossip protocol, and that starts exposing things. For instance, it exposed the API, it exposes the graphical, the web user interface, where we can do some operations from there, and that allows us to connect natively with Kubernetes, with Docker, with the StorageOS CLI actually, which is an operational tool as well. So we can do all these, and actually you can even implement your own APIs to ask provision a volume, remove a volume, mount a volume in this node, etc. So when StorageOS has started, it detects the hard disks that are in this node, and this is what we call the StorageOS pool. And pools can be of different nodes, and we can start adding selectors and decide which nodes we want for what. Let's say we want some of the nodes that are from Elasticsearch, but the other nodes for random applications like, I don't know, Tomcat applications that have input-output operation as well, but we will segment that. We can do that in StorageOS pool, and all the storage capacity, the hard disks, the physical hard disks, or EBSs, or wherever you want to plug into that file system, into that Linux file system, can be taken by StorageOS and be used to provision storage. So let's say we put an application, so let's say with Kubernetes we deploy that Postgres, that self-provision a volume, and we create what we call a StorageOS device, which is a presentation device in all the nodes. That means that no matter where the data is stored, StorageOS can present that data to any node in the cluster. This means that the data is in one place, maybe replicated in a different place, or 3 times, so we can have 3 copies of data, or 4 copies of the data, but the application can run anywhere. Yes, you will access the network when the application is accessing to a place where the data is not, and you will access locally in the local file system of the application when the node, when the container runs in the same node. And I'm going to go into this later on the library. So if the Postgres moves, because the node goes down, for whatever reason it is, the data is accessible. In this case, let's say we have a volume that we define a Postgres, and we decided that we wanted to define one primary volume, so one copy of the data, and 2 replicas. StorageOS has awareness of where your nodes are running. Let's say you run in AWS and you run in different data centers and different AZs. The replicas will be provisioned in different availability zones for high availability components. You can remove that, but by default is such as this. So the data is going to be written or read from the primary volume and for local file system, and that is going to write into the other 2 replicas in parallel. And when all of the 3 places have acknowledged that the write is done to disk, it will go back up to the Postgres, to the application, and say, yeah, the write is done. Why is that? Because for things like databases, you cannot have eventual consistency at that level. Because if you lose data in the middle, you have network partition, a data loss or a node loss, you're going to lose data. That cannot happen. You cannot corrupt a database and try to start it again and say it's corrupted. I cannot start. Try to rebuild that if you're lucky without losing data. Spend 4 hours at 3 a.m. in the morning with a production cluster or someone shouting at you. Not cool. So we trade latency for availability. So the data is always, the integrity of the data is mandatory. Also, I would like to mention that because we know that we're writing through the network, we are implementing an algorithm for compression. That what it basically means is that every write that we receive, if the data is compressible, we compress this before it goes to network to disk. So the data saved is either compressed or compact, if you want to call it that, and if it's compactable, which means that we try to minimize the traffic that goes through the network and to disk as well. What happens if I lose a node? Right? The node where the application was running, and where actually the primary volume was living, where the data was actually in. What happens basically is that StorageOS detects that and takes one of the replicas that was available, this one. It promotes this as a primary in a matter of a quarter of a second. The application can start wherever it starts, the data is going to be ready. And because it has detected that there is one replica missing of the one that I'm supposed to have, remember that this is declarative, I'm supposed to have 2 replicas, okay, 3 copies of the data, we start another replica. So this one is a new replica that starts syncing. While I'm syncing, yes, you can read and write to StorageOS. So every time that a replica is provisioned, a new copy of the data, fresh copy of the data starts writing, and when it catches up, this is considered as a healthy replica, and now all the writes are going to wait to acknowledge that replica, but not before it's synced. Also to mention that the StorageOS thinly provisions the volumes. So if your Postgres asks for 100 gigs of data, but you're only writing 1 gig of data, this is quite obvious, but it's not always like that. We write only 1 gig of data. We're not going to ask the 100 gigs of your disk yet. You can actually have less capacity in your disk than that. You can tell the application, I want 100 gig disk, but actually in your file system there is only 50 gigs available. You can tell the StorageOS, cheat a bit, tell the Postgres that you're fine, and next week I'm going to plug a new disk. And what happens if I fill the disk before I can write? StorageOS is going to complain and say, I cannot write, as any other disk will. So, architectural models. There is 2 architectural models, 2 principal architectural models. The first one is what we call hyperconverged, which means you deploy StorageOS in every node, and every node publishes the disk available to be used. So you can use data in that disk and read data from that disk, no matter where you're building. But sometimes you have auto-scaling groups. What happens if my auto-scaling group goes down? One of the nodes gets shot. I don't want to lose data. So you can start selecting which nodes have data and which don't. For instance, we can decide that these 2 nodes will not hold data. So in this case, the Postgres application will read and write through the network. Actually, there is a cache for reads, but we'll write mainly and have a cache for reads through the network. Why? Well, maybe I want my applications to be not a scaling group or some nodes that move a lot. And that's actually fair. So you're allowed to do that, but if you want to have high performance and low latency, you better put local volumes. So again, we try to be agile here. How StorageOS works and integrates with Kubernetes. If you have worked with Kubernetes and you have a PVC, you know how a storage class works most likely. So you have an administrator, an admin of the cluster that provisions a storage class. How the storage class looks like is a Kubernetes object. This is just YAML that says a bit of the definition of how Kubernetes looks like, or how the storage class looks like actually. Once I have this, a developer comes and claims a persistent volume or a persistent volume claim. And this is, hey, please give me a chunk of data. I don't care how, I don't care where, I don't care how it provisions. I just want some capacity. And this is something you can do as a non-admin user. How does that look like? A persistent volume claim that references the StorageOS class. So, and that's all. So your Kubernetes integration or the Kubernetes volumes that you provision have no difference when you use StorageOS or not, because the integration is full. The only thing you have to do is reference the storage class, which is a Kubernetes object as well. So we have a nice object-oriented split of concern here. So here we request 125 gigs. Automatically StorageOS will provision this volume for you and will make it available. I'm going to go in the live demo for this in more detail, so you can see exactly what it is. So when this happened, the claim has happened, and now the application can read and write to a file system that actually I don't really care how it works. I just want it to work from the application point of view. Finally, StorageOS have a management view, a CLI, user interface as mentioned before. We have a Prometheus endpoint with Grafana dashboards. You can start seeing how your input-output operations happens in the backend, how many IOPS are you reaching from volumes, how much bandwidth do you see across your cluster, etc. The UI looks like this, but I'm going to go in the live demo. I have roughly 10 minutes for your beer. Just hold it in. And I'm almost there. So you have a UI, is accessible through the browser, a Prometheus endpoint, and now I'm going to move to them. I think I have 5 minutes, if that's fine for everyone. Yeah, cool. Do you have any questions here?
Yeah, definitely. Has anyone got any questions?
Moving fast.
Before we do that.
So we predominantly try to use PaaS offerings for our databases, be that SQL, Mongo, or whatever. But I take it that obviously if you've got a local database on the same node, then it will be considerably faster. Do you have any rough kind of benchmarking as to what kind of performance increase you get, for instance, having a Redis cache, for instance, on a node, opposed to having a cache as a PaaS offering? So I imagine it's quite a lot.
That depends. Replicas, no replicas. The performance, it's a whole topic at StorageOS, and we have people that only spend their time on benchmarking on performance tests because it's a whole world. I would say that it depends. For instance, with Amazon and EBS, when your application have a lot of reads, we have seen actually we maximized the EBS throughput times actually 3 or 4 times because how the cache works. When you write, of course, you have latencies, and when you write with replication enabled, the latency impacts on your network, and this gets it depends on the network as well. It's roughly, I would say 70–80%. It depends on the amount of replicas, the amount of the network capacity, the network bandwidth, and stuff. People that run in multi-data center on-prem don't usually see that much of a hit.
It's the biggest question we get asked every day about performance, and the reason we don't publish stats is because there are so many different variants of it. In other words, it depends what database you're running, it depends about your network, it depends on so many different things, which means that if you give us a specific example that you're running in your particular equation, then we can work out.
To give you an idea, every time we buy new boxes, and we have physical boxes for benchmarking to be compatible, we have to ditch all the data we have from before. Because the machines are not the same, we don't ditch the results, but the comparisons between versions are not actually at the level, they are questionable. Because, for instance, last week we changed the network in the office from 1 to 10 gig cards. They're not comparable. So the performance, of course, relates to hardware. And yeah, you have, as I said before, you treat a bit of latency for the consistency.
So Ferran's going to do a live demo now. Hopefully it'll go well. For about 10 minutes, and then we'll have pizzas maybe.
Depends.
25%.
You might have some more time.
I'm going to keep it.
So we're going to, you can ask questions during the pizza or now. We're going to be here till about 9:15. We're based in Holborn normally, but it's only an hour up here. Yeah, sorry.
You mentioned about the cache. Is that a distributed cache?
No, it's a local cache in the machine that mounts the volume.
So for the time being, those other nodes won't have that information?
No. It's a cache that warms up when you use that mount.
And how long does that, is there a way to determine when that cache gets pushed?
In the latest release, we capped the cache to 500 megabytes by default, but we used to, and actually you can enable this, to get a cache that is based on the size of your machine. So what we used to do is if your machine is less than 4 gigs, you use a 2% tops. If it's more than 4 to 8 gigs, we use, I think it was an 8%, and you go all the way up to a 32 gig machines that we used to use a top of 12% of the memory. And now you can cap it by size if you want. because actually your Kubernetes cluster might have different size machines. So capping everything to one size might not make sense. So making our own percentages actually help a lot of people.
Just before I Fran gets on with it, the sweet spot for tonight would be, and this is the application there, it would be a mission critical application which Sainsbury's is running on Postgres. The orchestrator would be Docker EE. The storage would be StorageOS. The platform would be AWS. And yeah, that scenario would work really well. Or on-prem. So where's this demo coming from?
I'm going to show where it comes from.
Okay, cool.
So everything I'm going to do is in a GitHub repo, publicly available. Anyone can check, and I check the size of the letter before, so it should be okay. It's really tricky, but you can see the repository here. So this is publicly available, it's in GitHub. Anything I'm going to use are just YAMLs that deploy on MySQL. So to give you a bit of context, and then I will not even go to the other one. I'm just going to deploy a few nodes. All the nodes have storage. As Patrick says, it's AWS. I'm going to deploy MySQL with one replica. It deploys, the Kubernetes will bootstrap the MySQL, whatever it bootstraps, I don't really care. You can actually define that you want StorageOS to bootstrap along to the volume. It's just very, very simple configuration, and then we'll see what happens. So I'm in the repository. What I'm going to deploy, I have a few YAMLs. Actually, I'm going to give you more context. Forgot to do that. Sorry about that. So what I have here, this is the Docker Enterprise Edition Kubernetes provisioner. So it's one form of Kubernetes manager. I can provision here Kubernetes nodes. I can provision Swarm nodes. We operate now operate on Kubernetes only nodes, not in Swarm, but some people like can migrate things or have some stateless applications in one place or another. So this is actually quite nice. The UI works really nice. So I have few nodes. Actually, here I have one master. You cannot see here, but this is the master. The rest are workers. On the master, I'm not going to provision StorageOS. I'm not going to provision containers. I'm just going to use these. Usually, you have 3 masters. I'm just going to use one for the sake of the demo. And actually, from here, you can start managing a few things like grants, who can access what, namespaces, etc. I'm going to use the command line interface, but actually this comes really handy to start adding nodes, moving nodes, health of the nodes, have a whole scope and vision of what the cluster is. Again, we integrate with Rancher in the same way, we integrate with Openshift in a very similar way. Openshift is way more complex. I'm a big fan of the simplicity of this, but everything has its strengths. So when I go to the command line, I'm going to go to the namespace, search at namespace. From now on, I'm going to use KS as for Kubernetes, kubectl, kubectl, whatever you want to call it, on the StorageOS namespace, just for making it fast. Hope you can see. Cannot see exactly, but what's happening is I deployed StorageOS and it deploys at the daemon set. That means that every one of these containers is deployed to a different node. Right? As explained before, but it's a daemon set, deploys everywhere. We have a cluster operator which helps you a lot with that, so you can actually select worker nodes and where you want to deploy. So you can see here the master is not there because our operator checks who is the master and says, no, don't deploy here, deploy only on the nodes that are labeled with workers. And so only those nodes will use the StorageOS. Cool. So I have these. Where am I? As I was saying before, I have a few YAMLs. These YAMLs are the way to deploy MySQL, and I'm going to open the most important one. The other ones I'm just going to deploy. For instance, namespace called MySQL. So while this is deploying, I'm going to show what is in there. The most important one is the stateful set. I'm just opening a normal YAML, Kubernetes YAML that deploys a MySQL image with one replica, bit of configuration, and I want to go to volumes. So I deployed just a 5.7 MySQL. As I said before, it doesn't matter if it's a Postgres, or MySQL, or MongoDB, and Elasticsearch. And I defined a volume claim template. What is that? A volume claim template, if you're not familiar, only work with stateful sets, which is a way to say every application, please provision a claim. As I said before, a claim will map to StorageOS volume. So this is telling with the storage class name fast, which is the one I assigned to StorageOS. You can assign multiple storage classes for different configurations. Provision 5 gigabytes of data for every StorageOS container that you start. So when this happens, I provision, and I hope you can see this, that automatically, when I provision this, creates a persistent volume claim. This persistent volume claim, because it uses StorageOS class, automatically Kubernetes will talk to StorageOS and say, provision a volume of 5 gigs. So I went and do that. So if I go to the StorageOS user interface, and I check out the nodes, actually you can see that I have all the nodes that are provisioned, that are all the nodes of the daemon set. And I said, in the MySQL namespace, at the top you can see namespace, this maps to the namespace that I deployed the persistent volume claim. So without telling anything, automatically I'm segmenting on namespaces, Kubernetes namespaces, on how StorageOS sees things. So I'm going to go to the volumes, and we can see actually that there is a volume provision. That volume comes from that PVC. You have to do nothing else than this. You have an application up and running with a persistent volume claim provision, and actually dynamically provision a StorageOS volume. And actually you might think, well, why are you having a note here that says, I don't know if you can see, that says total replicas 1, available replicas 1. That means that the volume is replicated. It means that there's 2 copies of data, the primary and the replica. And how is that possible if I didn't specify anything anywhere? Well, I created a rule before that actually maps any persistent volume claim that has the label app equals MySQL. Make sure you add this label StorageOS.com/replicas. Right? This is what we call a special label. Anything that has this label will have one replica. If I change this label of replicas 1 to 2, automatically StorageOS will provision a new one. Right? These labels, I can create them here, and because the PVC had this app equals MySQL label, automatically StorageOS does what it has to do. So from the operator point of view, you can do that, but you can also do that from the persistent volume claim level. So you can also do that. This one. From a persistent volume claim definition. You just have to add the label, StorageOS.com/replicas equals 1, the same label as before, and StorageOS picks that label and actually knows what it has to do. And there are things such as compression, encryption, there are things such as how many replicas do you want, which node do you put the master, what we call a hint master, just please try to put the master there. There are a lot of functionalities that you can trigger by this, but hey, the developer can do this. Maybe you don't want to give the grant to the developer to do that. Then you can go to the rules and ensure that whatever happens there is the truth. So we segment the level of what you can do from different layers to who can do what. So by definition, you can create labels and replication, but maybe as an operator, you don't want to allow this. So going to the example, starting on MySQL. So we have a client in a MySQL pod that is mounting that PVC that I just showed before. So let's, for instance, add some data. This is just a client that I deploy along to MySQL, so you can see how actually it connects to stateful set service. Most of you are familiar with this. The ones that are not, it's just a MySQL command. I have my SQL prompt, we have the database mounted in our file system, and I'm just going to create this. What did I just copy and paste here that you don't even have to read? Simple. It's just a tiny table on a MySQL application, just random data, right? So now, and I'm almost finishing, is where is the pod running? Where is the MySQL running? The MySQL running in the node 236, right? Where StorageOS sees the volume living. You can see the StorageOS volume is mounted in the 236, but actually is living in the 45. It could be living in the same node. It can live it somewhere else. You can mount through network. StorageOS will handle all these. But actually, more interesting is what could happen if I lose a node. And I'm going to simulate that. And not to waste your time, I'm just going to go through a node. Actually, hold on a second. The node where the data is living, which is the 45. No. It's 166.45, where the data is living. And you see that there is a master here. There is no replica. But the master is there. That means that the main data is there. We have other two replicas because I have a backup plan if this fails, which is a replica in a different node and a replica in a different node. Right? I have a different namespace with the same application. And you see that the master is at the bottom. So I just have two MySQLs now running in the cluster, just for safeguard. So if I come to this node and I say, drain the node, I'm going to trigger the same logic that happens when you lose a node. I'm going to drain the data that is living in this node to make sure that I don't want data in this node is dead. Right? So, let's see the 4 nodes. I drain. What happens is automatically that master goes to replicas, and actually the master has been promoted here, and a new replica has been created in a different node. Right? So I can I just faked that I lost a node. So where the volume is living now. What's happening? The volume is in syncing mode, and I'm passing that. But what is happening now? Look, the node, the master that holds the master location, is a 19, and it's mounted as before. The mount didn't change. The file system that the MySQL sees haven't changed at all, right? But the data is actually serving from a different place, and hey, this is healthy. In a few seconds, because there is barely data in there, because it's a small amount of data, and that's why I do it, because now a new replica has been created, is in sync, is healthy. So now the replica is in a different node, right? And actually, we even have functionality that if the pod lands where the replica gets promoted automatically. But that's not. So what happened to the application? I go back to the application, the data is serving from a different place, completely. A new replica has been happening, it syncs, or it actually doesn't matter if it syncs or not, the data is still available. Your application, the MySQL sees no downtime at all, most cases. But, so we do a lot of magic under the hood to make sure that the application actually is healthy and have high availability. I could be able, if I had time, to do the same with the application node. Should the node that runs the application will start somewhere else, data is there. Right? So you lost a node, you lost a hard disk, you lost something like that, automatically you have access to the data. And just to finish, a small recap. Sorry. Sorry. So I deployed the MySQL, had the master had the replica. I should know, actually they were not running in the same node, just by chance, sometimes it does, sometimes it doesn't, you can choose, but for the simple configuration, a master has been promoted, read-writes keep happening, no problem, and your replica has been synced. Like demo slides. And you can have data now.
Yay!
Any questions, anything you want to know? You can feel free to go to the beers and keep asking questions. Okay.
It was just about the master one. So if the master then goes down and it goes across, is there any point where you have a preference over a node, so it will go back to the master once it's live? And up?
We're implementing that right now. If you have 3 terabytes of data on one volume, you don't want to ditch the whole volume when it comes back up, right? Because maybe it's just a restart. We're implementing that right now. More questions? Yeah?
Do you back up data outside of the nodes? So could you have a scenario where all of some massive failure where all your nodes go down?
We are not currently doing that, and the way to do that, we start looking into snapshots, and we're thinking to implement snapshots. Actually, we have a draft for it, but what happens is that it depends on the application that you run, because this actually what we provide, I didn't say that, is a block storage. And then you create a file system on top of that block storage. Usually, how you react to the block storage is how it depends how you backup things. For instance, if you backup a snapshot byte to byte a Cassandra, you will not be able to recover that. You need a Cassandra tool to backup this. You can do that with MySQL, with some Percona tools, that you can actually copy files and make the metadata work. But to the answer, no, we don't backup things out of the box yet. We're building the snapshots, but it will work to some applications. Also, some file systems need to freeze to be able to do snapshots. Actually, anything that runs in EBS does that. It freezes the file system for a few seconds, maybe 1 or 2 seconds, takes a picture, and it unfreezes the file system. Something like that is going to happen. Any questions? So, sorry, to finish your answer, we usually recommend people to back up at the application layer. You can actually mount the StorageOS volume to save those backups as well when you move them anywhere, somewhere else.
How long would it sync? How long would it take to sync if it was a bigger database? Because that's like the smallest database in the world. So.
Yeah, it depends on the network. I have data, I want to copy this data here to there. All this data is compressed. So for instance, database is highly compressible. And as soon as we have this, we start shipping data around. We have quality of service if you don't want to bottleneck your network. So you can do that as well. But it's not dependent. Yeah.
You said highly compressible. How much compression can you get?
If it's text, for instance, or Git repositories, we see 60–80% compression. Which means that also the amount of data you save in the disk, if you're paying for EBS, you pay less. But it depends, because there is some data, for instance, video or images that are already encoded. You cannot compress this. So the StorageOS compression algorithm detects that and just don't even try. You just send it over. Yeah. So the answer is it depends on the format of the data. More questions?
So the compression you're using, if you have a backup and if all the nodes goes down, is that incompressible? It is standard compression?
Well, you can run the compression algorithm, but I wouldn't say so. I would say take the files, because actually what StorageOS does is all these virtual, what we call devices that we register to the kernel, are things that the application sees, and it sees a device. But that device, under the hood, ends up passing through StorageOS, all the cache, all the compression, and it ends up writing to a byte, what we call a byte file, or a blob file in the file system. And for each volume, we decide which blob file this is. So if you actually take that blob file, and you restore the whole blob file, we take this as a sector-based or SSD-based disk alignment. So you could be able to recover that. And actually StorageOS will see, in the position 3, I had the byte, I have this byte. In the position 26, which is what the disk does in the end. So you could be able to recover from there.
Without using any other tools?
Yeah.
Is that how that is done?
Yeah. I guess they could have some manual intervention in there. Yeah. I can smell the pizzas, I think. Everyone's hungry.
One more thing. If you want to try StorageOS, then we'll send you the details. But there's up to 500 gigs of storage for free, and that's the developer version, and that's for free forever. So
full functionality, replicas.
Yeah, it's got full, it's got encryption and locality and all the functionality you can get in the developer version. It's the same as the enterprise versions, and they are based on capacity, so per terabyte, or node based, minimum 3 node cluster. And if you're interested in those, then talk to me about pricing. But if you want to just have a go for free, then we'll send you the link for it's from the Docker.
So if you have developer cluster, you just deploy the operator from the GitHub repo I just showed. Deploy operators, deploys create StorageOS cluster, which is a YAML. That's it.
Thank you very much.
Who uses Docker? Who's never heard of it? Has anyone ever heard of it? Hello. That's one after. Yeah, so good. So the rest of you have, great. Does anyone use it on like a daily or weekly basis? Everyone can like, okay, fine, right, cool. So on the conceptual side, we're all good. I hope, apart from that one person who I'll talk to. So there's a bunch of information, a bunch of different topics really on this one. We've just come out of last week, which was DockerCon, which is our annual shindig. This one was in San Francisco, so it was at the Moscone Center. And basically, it's when we make lots of announcements, and there's lots of like up-to-the-minute content which comes out of it. So I tried to get some of that together for you. Some of it's going to be right up your alley, some of it might be really like not, but I'm going to get a lot of it, so that's why. And I'll try to make it quick. I do like questions. I sometimes can answer them as well. Cool. So, without further ado, if you haven't played with Docker much, or if you are, you're joining a growing number of people, a growing practice. We estimate with our telemetry there's 45 million Docker engines out there. And if you're using Docker for desktop, Docker for Mac, or Docker for Windows, if you don't, you should check it out. There's 1.7 million of them now, which is really very good for a developer tool, especially a new developer tool. And so very widely popular there. And by growing like a clip of something like 6-7% a month. So we're really going to be like 2+ million quite soon. Lots of apps, apparently not try that version. But then also image container pools, right? So if you haven't used Docker before, it's a way of kind of encapsulating the software your software you want to run and all its dependencies in a container image, basically, which is like a tarball, a zip file, something that you can go and get and distribute. And we've had 105.2 billion container image pools since the inception of the Docker Hub a number of years ago, which is an insane number. So that's good, isn't it? It means that lots of people are using it. Okay, so Docker Enterprise is part of what pays the bills at Docker. And there's lots of other things, lots of other kind of lines of business that we're involved in, with partnerships and such. And so here's just a short list of some of the things we announced. I'll step through them all. So if you are using Docker Desktop today, it's probably called Docker CE, Community Edition, which is available for Mac and Windows. And in response to popular demand, we're now doing Docker Desktop Enterprise. I'll step through what that really means in a bit. Docker Kube Service, DKS, Docker Kubernetes Service. So Kubernetes is an orchestrator for containers, by the way. So we've had some Kube operate for a while, but we're now making it official with a 3-letter acronym. So you know these days unless you've got one. Docker Applications, which just sounds very vague. So just speak to marketing about that. But it is a thing. It is about how we describe applications we want to deploy. I'll come to that as well. And then we're doing something called Docker Enterprise as a Service. Welcome to that too. So, I'll get to it. Right, so first one, Docker Desktop Enterprise is, if you haven't used it, or Docker Desktop in general, if you haven't used it, is the kind of vendor shrink-wrapped developer experience for Mac and for Windows. Okay? So Docker initially at least was just a Linux thing. Okay? So it uses the Linux kernel to give container capabilities. And of course Mac is not Linux, and Windows is most certainly not Linux. And so people wanted to be able to continue to do that. Things with Linux, with Docker, but found that quite hard, and there were ways around it, like using virtual machines, VirtualBox, things like that from Oracle, which are quite unpleasant. And so what we did, we came up with a bunch of tech that basically makes that very, very easy. Hopefully that's your experience too. So you install it, and then you just get a background VM that you don't have to manage. You don't have to install and install an operating system. It's all just kind of self-updating, super easy. And then once you've got that, it plumbs really nicely into your development experience. You can do local development. So you've got like a nice local feedback loop. You can mount your code in, it's interpreted code, you can see your changes live, debug live. It's all very nice, really. And that's on Windows. We do one implementation, which is based on the built-in Hyper-V hypervisor. So it is a VM, just all managed for you. And then on Mac, we use the built-in, or rather unused Beehive hypervisor underneath, and some very clever other projects that we're not famous for that handle things like networking and other bits and pieces. So that gives us like a really, that's why it's so popular, we like to install it, and then got great. So in response to kind of popular demand, the problem with that is that it's kind of unmanaged. It is just like, it's a developer tool, so they're generally quite free and easy. Docker itself out of the box, generally quite free and easy. And that just will not fly in some enterprise environments like banks and such. So one of the main problems really is it's largely unmanaged. Settings you can apply, configuration, security, things like that. And the other problem is it's just quite hard to distribute because it's a meta install that goes and gets loads of packages from the internet. So those two core problems are solved with Desktop Enterprise basically straight off the bat. So everything is distributed as MSIs or basically MDM, mobile device management friendly package formats. So you just go and send it to your fleet of systems and your developer waits to whenever they got or install. It's all nicely managed. And then the other half of it, the configuration side, that's all handled through, can be handled through group policy, or if you're using Jam, which is a Mac manager tool. It's a bit of a problem because Mac developers don't like their stuff to be managed, generally speaking. They shy away from that. But if it, it's a necessary evil in some environments, so we are solving that problem. This is part of what we call Docker Enterprise Platform 3, which will ship in the middle of June. I'm already using it in beta, it's here. I'll show it to you in a minute, and then go over. So one of the other things that's really nice about this is that you can have it match your destination, your venue where your containers go to run. Should as much as possible be reflected in every stage that precedes it, where your containers are being built and tested, right? So in the case of Desktop Enterprise, what you can do is you can select a version pack, which basically says, well, when I deploy over here, that's going to be running Kubernetes 1.13 and Docker engine under that based on, 1809 or something like that. So these packs basically you can switch between them if different versions of places. And that's nice. That just means that you get a realistic experience. You know that you're not using any features that might now be available in the place you want to run, etc. So realistic testing, etc. So really nice, and that's also an initial question. And within all this was what we give the developers some nice tooling for sort of starting or building projects with Docker. So if you've used Docker before, you might have seen a Docker file before. This is like the standard way to create a Docker container. So if you're used to doing a scripted install, we largely just, we go and get some OS from somewhere by saying from this, and then we run some commands, and that builds our container for us. That's basically what we need to know. So this is what's always been part of Docker. It's sort of, always been part of the process. We very recently just completely rebuilt the build engine in Docker, by the way, to use something called build kit. Okay, so if you care there being an open-ended way in order to how to describe how your containers are built, this should be interesting to you. So for lots of people, it's just part of the plumbing. It's just the thing that's invoked when you say Docker build. But that's been completely rewritten, and it's marvelous. There's a lot of stuff about that, which I'll come back to in a moment. So that's like the simple use case everyone is aware of. Another one that we are shipping out is something called Docker Assemble. So you can imagine a situation where, I have never used Docker before, or I have, all I've got is, I've come to work and I've got all this source code, and we've got some standards here maybe, there might be, we use Java, etc. This is a Java example. So, we can just say Docker Assemble in a directory with our source code and detect, or attempt to detect, what's really in play here. So in the case, in this case here, it's going to be Java application. It detects this Java application. We've got some opinions about how a Java app should go into a container, and we just do all that for you. We know what we're about to do, we just do it for you. So that's quite nice. Rather than having to start from the outset, let's start a new text file, let's do from this to that, we can just point it to some source code, and then go, here you go. Here's your container here. So that's Docker Assemble. That's also part of that software. Okay, the next one, and this is really to do with like a migration use case now. This is the app converter, right? So we have customers who are running software that they do not have access to the source code for, but they do want to containerize because they might be relocating the software, moving away from a legacy platform or an existing data center, something like that. So we can point or run this on the actual server, and this goes way back on Windows, also goes way back on Linux as well. It's just a binary, and it will run some discovery inside the system. So if you're running no middleware to us, this is all pluggable, of course. So we've got some support here for obviously Tomcat, also .NET and IIS, and WebSphere and WebLogic, which are super common in our customer base. So you basically run that on the server and go, right, well, those middlewares keep their configuration in a known location. I'm going to go and fetch that, I'm going to go and parse that, and then I'm going to go and collect all of the software needed to recreate that in a container, and then build the image that way too. So we're really just trying to compress that bit between, yes, I want to do this with Docker, to getting somewhere that doesn't involve, knowing more about it already. From our perspective, consider it from our perspective, right? We want lots of people to buy and use Docker, obviously. And the way that you expand the market for that is one of two ways. One, of course, is let's bring more apps and make more apps eligible for running as containers. We're working on that a lot. The other one, of course, is just to make it easier so that everyone else can use it, right? And so that's what a lot of this tooling is about, really, about making this stuff as easy as possible. Indeed, Docker, you could argue, became famous for making what was once pretty low level and pretty painful, which was actual container technology in the Linux kernel, quite easy, quite consumable. So we're not done on that whole mission yet. So another one, and I might just show you this actually, is just Docker application templates, right? So this is kind of that net new use case. So this is like, I'm going to sit down today and I'm going to write me a new app. Okay. So let's actually dispense with this for a second. Okay. Cool. So I'm running. This is a little bit of this one probably. So fingers crossed everyone. But I will. I'll fire up this app designer, which is quite cute. Cool. So I've got some applications here. Let's just have a make a new one. Now, I can choose a template. In fact, I can go custom. So I can basically, if I want to, policy and such, I can step through here and I can choose which things, Django, for example, and let's have reverse proxy, and yada yada yada. MySQL, for example. So I can choose these components, and then I can go and assemble them into an application. So rather than actually, again, starting off with just some core components instead of stitching all that stuff together to make a stack, we can just do that graphically, or alternatively, You can't see this. Can you see this in the back? A little bit? This says Django, this says Linux, this says MySQL. And then down here we've got some configurable stuff. So we can choose the Python version and play, Django version and play, which ports is published on, etc. The other option though is things like targeting. So what's nice about this is that if we have opinions about what stacks we should be using inside my company, we can prescribe that. We can say, here's the approved stacks, or here are the stacks that someone should use. And so these are already kind of here waiting for me. And so these are already published. I can say, yes, I want one of those, please. Let's just do Crafty in here. And fingers crossed, I'm turned to my phone by the way, so this is a reflection of the performance of how it would work when applied properly. Anyway, so it builds a scaffolding, which is nice, right? So I've got all these components that I want, and it's going to go and basically give me some nice, easy to consume opinions about how I should get started with that. But the result really is that I can actually just start straight away. I can put my source code in there, and I can hit run now. And that's actually just going to use Compose to bring this up. I can also just fire this up in Visual Studio Code now. There it makes up. Yeah, here we go. So I've got my context here, my directory. And within that here I can see that I've got, for each one of these layers, back DB in the front, I have, the ingredients I need to build that basically. So I can get started straight away. I can make edits if I need to. It even gives me things like a compose file. So that's actually what's being run right now in order to start the upload of my machine. So this is nice. This is all just ways to get people started like as an on-ramp really quick. All good? Any questions? Who doesn't have a question? There we go. Thank you. Someone's waiting. That's good. All right, I'll run with that. Okay. So that's nice. Cool. So the next one is around working Docker applications. This is related to some other work we did recently with Microsoft. And there's this idea of something called a cloud native application bundle. I think we'll go after you try the difficult words to you. And so the idea here really is that we want to try and make a way of packaging up applications that kind of decouples the config from the descriptor, if that makes sense. So you've got your descriptor which says, well, I want one of these, or one of these, but in different environments like in staging and in production or locally, you're going to probably have perhaps different scale at play, enabling or disabling your debug, that kind of thing. But what you don't want to do is maintain 3 sets of otherwise identical files. So really what we have is the descriptor, and then we have some different settings that we can apply, and then we can actually throw all that together as a single bundle, and then from that spit it out as Kubernetes YAML. We can use any some Docker Compose for local, Docker Swarm YAML as well. We're working with Swarm, and one of the unforgettable, the help as well. Spit it out as help templates as well. So this means that you kind of have just one way of describing it again, and then you decouple as well the config, so got a nice kind of parameterization of the deployments there as well. So the idea being that we can do this differently each different place, but basically one source of truth. And also the work is going into the registry component of Docker, everyone familiar with registries presumably as well, to handle non-image content, including these bundles. Okay, so like the actual idea of what a registry is for is kind of being expanded to also include non-image content as well, like these bundles, like lots of other things as well. All good? If you haven't seen Docker Enterprise before, it's actually not just that developer piece, but also the kind of the right piece as well. So our registry that we vendor is a software that you can deploy into a cloud or you can deploy on-prem is Docker Trusted Registry. And so those arrows aren't right. I apologize. conversion, I think, from DDoS. But you get the idea. That becomes basically your source of truth inside your organization. You can deploy it on-prem, so it can be nice and top-down, deploy it in the cloud if you want our functionality available to you in the cloud. And it's not just about having a bucket for your images, it can also scan your images for vulnerable content, vulnerable libraries, anything we recognize as a potentially out-of-date or vulnerable binary using the CVE database. And we can also do digital signing as well. So another fantastic project we are absolutely not famous for is Notary. Notary in real life is someone who signs on your behalf in another jurisdiction. And the name of that project is actually given to handling digital signatures for content. So Docker Trusted Registry includes Notary. And basically the real idea is that unlike something like GPG, which is sort of like a single key that you use for signing content, we can have multiple actors signing content between the developer and production. So I, as a developer, can actually, when I push my image to the registry, it can add my digital signature in the background. It's now non-refutable that it's coming from me. And then when we move ahead through CI, with one of the directions of those arrows, when we move through CI, Jenkins itself, could sign that image to say, yes, this is a deployed equivalent. So we have multiple signatures applied to a single piece of content, and then that really gets coupled together with our Qubit one because we have we can control the policy basically, who we trust. Do we trust just the developer signature in this environment, which we test, or do we have to make sure absolutely everyone signed off on this thing to get to production? Well, if you have done that, I think you get pulled, I think you get deployed until all the signatures are going to be present. So very, really nice security properties for that. And also what's really nice about it as well is it doesn't slow you down like the way security normally does. Historically, we've dealt with security through oversight and human beings. And if we want to keep all of that nice goodness and agile goodness from using Docker and that security, that's really nice. So our registry does that, as I said, as well as scanning, horizontally scalable service, deployable anywhere, you should check out. The control plane as well is part of our offering as well. That it basically is our API into running our clusters, wherever they might be, so Q clusters. So it basically proxies the API into the environment, so as a user I can interact with it using the kubectl command, the Docker command, as I am used to do. But everything I'm doing is being audited, of course, and also access control. So every time something's coming in, we're doing a quick look at that to see, do I have the right role? Am I accessing objects that I'm allowed to access? And we're keeping the audit of that anyway. And so you can keep working in the way that you like to. So you can work on CLI, you can work with the GUI, which was like a moment ago, or you can work via API. You can use, you can program it. Fine. But the experience is absolutely industry standard in that sense, 100% API compatible with open source. But you have all that kind of goodness around it, keeping things safe. So yeah, we can do that on whatever infrastructure you like, including bare metal. Got quite a few bare metal customers out there for the performance. Windows and Linux, by the way. I know there's a lot of .NET here, probably not all of it on Windows either, but we can do Windows containers as well as part of this cluster. Obviously, Docker in the container engine is still pretty much the container engine for most container products today, and your choice of orchestrator. Our kube service is the kube component of that. So, as I said, 100% API compatible. Kube will arrive on Windows if you care about that. Does anyone care about that? Don't care about Windows? I was shaking it. Okay, don't mind. But yeah, Kubernetes basically, or containers in general, lags behind on Windows, by the way, because of Windows. It's the Windows kernel. We get loads of great stuff from the Linux kernel for free, like firewalling and IP load balancing and things like that. Straight out of the box with the Linux kernel. Windows had to catch up with that. It is catching up with that, and very soon it will have Kubernetes support. So we'll be throwing that in too. But yeah, this is part of our offering as well. You should check it out. Very easy way to set up your mic. It's the easiest kube setup I've done outside of managed service. And trust me, this sort of stuff. But yeah, this one. So in case you're wondering what it looks like actually deployed, if you don't, I'll be very quick anyway. But yeah, it's we have these basically these managers. You know, in Docker and Kubernetes and other things that basically share a lot of the architectural characteristics, we're using this idea of distributed consensus. So you have, you know, the same is true as StorageOS in fact. You have we use Raft, so that basically has an odd number greater than 1 for managing HA. So basically 3 over there. So 3 managers, 3 instances of DTR, and then some workers, and then we load balance across them, right? So we use external load balancers of your choice, or indeed the ones from your cloud. It's very straightforward. And then a big bucket there for storing our stuff, and we use pluggable storage there too. So between these things, what do we have? We have the management and orchestration components. We have your registry components and the registry storage for your container, which is, you know, a bunch of workers actually running your workloads, n number of them, up to many hundreds. And then of course your administrators, developers can be using Docker on the desktop. So we've also announced a bunch of, so one of the things that's happening in the next version of Docker, Docker's 1903, and you can get, by the way, you can get nightlies in Docker at the moment. Well, that's the other way we distribute Docker. So you can get a lot of this stuff right now. But if you're willing to wait for it to go GA, so basically one of the great things that's happened in the latest version of Docker is that we've basically done the CLI plugins. So what it used to be like, Docker this, Docker that, Docker this, Docker that, right? But then every time we did something new with that, it would be probably a new build of the whole daemon. There's been significant basically refactoring of the way the internal architecture of Docker over the last 12, 18 months. Significant. And that's not trivial when so many people depend on it. But one of the really nice things about it is now we can say, if we want to add some new functionality into the CLI for everyone's experience, it's just a plugin. Right? So this one here, for example, is Docker cluster. It's Docker cluster. So Docker cluster this, Docker cluster that. So if I want a new cluster, I can say, hey, Docker cluster create, or ls, etc. in this case here, and it will just go and provision one for me. You know, we're using some automation backend, again, which is actually also open source, but it will just go and create that cluster for me on the target of my choice, which out of the gate is VMware, AWS, Azure, I think GCP. And this is just one of them. So, and not just the deployment, but also maintenance. So when you want to go into the next version or whatever, we do it by this if we want to automate it. So again, another thing is just making this stuff easier for people to get to, because up until quite recently, if you were trying to do this any other way via a managed service, it was not going to faint of heart. So, can I just be clear, does no one care about Windows in this room? Good then, okay, well, I'll be very quick on this one. I'll ask next time before I right, just, okay, for trivia purposes. In this case, Windows authentication uses Active Directory. And when you use Active Directory, everything's got an account. Users have accounts, computers have accounts, and you create service accounts to authenticate and live in this LDAP. This idea goes all wrong when you start using containers which are ephemeral, basically. They appear and they disappear and they multiply. And so we have to give a different form of identity to containers. That we what GMSA is, a group managed service account. So basically it's sort of JSON credentials, a credential spec that we slip into the provisioning of a container that gives us permission to use Active Directory. But you can just get rid of that knowledge to you, okay? Cool. Another, people who care about these things as well. On the security side, we've got some really security conscious customers, I think it's fair to say. And so we've had a lot, last year it was FIPS compliance and things like that, so we have all like crypto libraries like read by someone in order to be certified. And this time around it's hostile as well, so that's like automated compliance and reporting basically for your environment. So you can basically just go like, are we meeting this benchmark? Are we doing it right? So that's really nice, and that's also showing that through it. Docker Enterprise as a service, by the way, we're like, this is for people who want Docker Enterprise but don't really want to manage it. And so this is now being offered through us and also by Capgemini, who do loads of stuff with our biggest customers as well. And yeah, so initially we do it on-prem with OpenStack, and we also work with cloud as well. So this is just meeting the demand for people who just want to just use it. They don't want to work with it, they just want to use it. Yeah. So that's that. Okay, so this is a new one. Okay, ARM. Okay, everyone familiar with ARM processors? Anyone unfamiliar with ARM processors? If you're unfamiliar with ARM processors, basically the world of computing has been mostly, we've been like, Intel for like since the 90s. For most servers, the x86 instruction set and processor architecture has just completely dominated home computing and server workloads. Well, along comes ARM, British company, awesome, and they come up with a completely different business model because Intel do the foundry right through the design and R&D and everything else. ARM have got a completely different business model where they do a ton of R&D, but they can basically lease you the design. Or they can do everything in between R&D for you and the lot. Everything in between, but they're happy to decouple all those things. So they get a massive check written to them by Apple, for example, or Samsung, because they get those licenses and their IP. So really nice, massive British company. Anyway, the point is that that's actually, there's going to be a lot more of those processes all around you in the next few years than any Intel ones, because they're designed basically for low power consumption and cost. So they show up in your phone, and they show up in your Alexa, and they show up in your coffee machine, or whatever smart thing you end up buying. We'll probably have one of those in it. Okay? So that means they are like a huge new development target for everybody. Okay? But the problem is, of course, it's not easy to develop on. You have to kind of ship your code to a Raspberry Pi or something nearby, or some kind of reference board. Seriously, and that's how people do it. But that's changing. So on the one hand, AWS now, they do A1 instances, which are ARM instances. They are so much cheaper than other types. In fact, I wouldn't be surprised if Lambda and their functions and things like that probably running on ARM. It's just so cheap for them. But again, we've got the problem how you develop. So one of the nice things we're doing now, so this boils down to number one, Docker Desktop. So we're going to actually do some ARM emulation inside that VM that we're shipping for you. So that means you can basically go and compile and run in a realistic emulated ARM environment and then go and ship to an ARM device or an ARM cloud instance as a single kind of workflow. In the same way you've been enjoying with x86 or ARM. So that's real nice. We're hoping that's really going to catalyse quite a lot of consumption for ARM. I'm certainly hoping that too. That's why we've been working on it. Again, we've already got ARM support in the Docker Hub, so actually run like Raspberry Pis at home, like a one-point cluster and things like that, running Docker containers. So we've already had that capability in the way images are stored on the hub, etc. So that's there. And yeah, so that's now coming to the Docker engine will be officially supported by us in that capacity as well. Yeah, it's 40% off if you run it in our server. So pretty nice. Any questions yet? No? Okay. So as I mentioned, engine modularization. It's not an easy thing to say. Engine modularization. Yeah, we've been doing this for a while. So it started off as just like Docker, like one project, and then we started decomposing that because it just became advantageous to the industry, or it just took that aspect of competition off the table. So things like your network and build kit and swarm kit, these are all kind of components that we bolt into Docker, but we kind of developing them as separate components because not everyone needs it. We get that. So we're moving further and further in that direction. One of the major components here at play, actually, which I'll come back to in a second, is containerd. Containerd is like a lower level component of Docker, which basically is the container supervisor. It's the bit that everybody wants. Like you might have, if you're running an EKS cluster, that doesn't necessarily need the Docker daemon, because it doesn't necessarily need to be able to build containers. So it's got all that capability baked into it. All it needs is that supervisor. That's becoming a very important component of that. So we gave that away to Cloud Native Computing Foundation, who are also custodians of Kubernetes. Yeah, it's a whole backstory. But yeah, so that's what that. Well, that's one of the major areas that we're working on now. Basically, decoupling all of these components. They can be assembled by us in our products the way we want to, but also by someone else in some other way, because reuse is a good thing. Okay, so when you work with containers, if you're unfamiliar, we have this issue of ingress, because when you relatively horizontally scale services on a cluster, you're going to want to inform something routing traffic to that service that the makeup or configuration or scale has changed. Okay, so we deal with ingress as a topic quite regularly. We're actually going to introduce Envoy, which is a very popular ingress project into Docker Enterprise as well, quite soon as well. So you should expect really strong support from us for that as well, and also for it to show up in Docker Enterprise so you can do realistic testing with that as well. So these are all kind of new capabilities coming down the pipe. It's looking ahead now, rather than just in version 3.0. And also looking ahead even further from that, we're moving towards also a services mesh. Has everyone encountered or heard of service meshes before, or not? You have. Okay, so service meshes are. No, this is getting. I find it hard to keep up sometimes with lots of this stuff. But when people run software in containers at scale, or if you would start a net new project based on containers tomorrow, you would probably run something like a microservices architecture. So lots of components that independently can scale from one another, etc. The problem is, which is great, because you can write them independently, you can scale them independently, it's wonderful. But that introduces problems around complexity. So securing all of these endpoints when they're talking to each other, and actually being able to trace what's happened inside them, becomes an issue. And that's why service meshes that kind of are out there to kind of address these issues directly. So primarily securing endpoints from one another, so actually setting up the crypto between services, so actually have a TLS between one service and another just straight away out of the box. Very minimal configuration for you, which should be another thing to take away from quite nice. And the other one is sort of traceability, actually what's happening between all the requests and from a request through this application. It used to be one application, right? It could be one log file maybe. Now you actually have to trace it through all of these things, and this has to do with that. So again, Istio is pretty much seen as a de facto, at the moment at least, leading service mesh technology. Other vendors have kind of jumped on that. We're going to do it to put it in products. So again, you should see that in the desktop experience and others. I mentioned containerd earlier on, but yeah, that's also graduated to being when you join like the CNCF, you kind of go into like an incubation project, and then you kind of build up, and then you get made, like math, get made, there's nobody like you're ready. And so that happened to Kubernetes once, and then that's happened another 3 times, and now it's happened to our products, which we're really delighted about. Because it's important infrastructure. So even the places that don't need Docker need this. If you're running containers. So yeah, it's graduated to being a full CNCF project. Now even under the hood, what we've been used to using is this even lower level component called runC, which is actually what just starts a container for you in Linux. But now actually there's a bunch of different implementations of that now that have different trade-offs. So one of them would be AWS Firecracker. You heard of that? that will start like that. That's actually like a minimal virtual machine manager that starts like a minimal OS with hardly any devices, such that an actual system boot happens in a number of milliseconds. Okay, so you get better isolation, and actually still having it quite lightweight and still quite quick to set up and tear down. So AWS want to use that for Lambda and for Fargate and things like that. And so instead of having containerd talk to 1C, they have a talk to 500 instead. So that was one of the talks actually you should go and check out after today. That was one of the ones from the guys at AWS. And gvisor is another one. Gvisor is like another way Google have developed to kind of isolate containers from one another, basically taking big parts of the kernel and putting it above the kernel and user space, so that you never actually have to talk to them. It's a whole topic. But basically, the point is, Kubernetes and Docker and Swarm and everything else wants to talk to a container supervisor. Containerd is the one, which is really awesome. So that's now basically been adopted by AWS and I know Google, and they send us patches, which is cool. I mean, the main sort of alternative to this is something called Cryo, that you might have heard of, about Red Hat, who have been bought by IBM, who work with us on this. So who knows what's going to happen. But so yeah, all the managed Kubernetes operators now use it. And we now commercially support it as well. So we've got people with products who want to embed it. SwarmKit. Any people use Swarm in the room? Or did anyone get started on Swarm? Yeah, why not? Cool. It's so easy. It's so easy. So we're adding batch and con support to that, something already present in Kubernetes. But something that people have been asking us for Swarm, because a ton of our customers and actually lots of users out there still using Swarm. It's just so straightforward to build and set up, or using Swarm environments as well. And we're also moving towards CSI support for Swarm, which will be relevant for you guys, I think. CSI is the container storage interface. So whenever a container, so basically the problem that's what we often have is these points of integration between containers and other things. Right? So in the case of networking, you had this, everyone agreed on a set of standards and called that the container native interface, container network interface, so the Sienna. And in the same part for storage, they arrived at the CSI. So it's not the crime show. So yeah, probably a bit less exciting than the crime show, to be honest, in fairness to everyone involved. Yeah, so the cool thing is that we'll be able to reuse all that hard work that goes into integrating with Kubernetes, we can just take advantage of that. And so kind of what I use as well. All good? So DockerCon is going to be out quite soon. That's going to give us NVIDIA GPU support as well in the engine, which is quite nice because Docker is increasingly being used in data science and machine learning and things like that. You can get cloud instances super easy now that have GPUs attached for those kinds of workloads, which is really nice. So, and there was previously used to be some fork of Docker that was had all the monkey patches in it to make it work well with GPUs. We're now actually just putting that straight back into Docker itself. As I mentioned, CLI plugins coming in this time around as well. So you can say Docker registry this, Docker registry that, Docker cluster this, Docker cluster, Docker context, which is quite nice. Docker context means like Docker context local, and now I'm working on a new cluster, Docker context production, and then I'm talking to wherever that might be, like new cluster somewhere else. And that it's just a nice way of reasoning about where am I actually working right now, because that's a very easy mistake to make. Anyone here doing all these things, know what I'm talking about. And also this excellent, so check the data Zookeeper from DockerCon, I think it will build X, and that's basically taking that build kit project I talked about, and basically just blowing it wide open. So like the demo that they did was having a image being built in parallel for for x86 and for ARM simultaneously, and then pushing into a registry simultaneously. So it's really just blowing open all of that tooling around build in a way which is extensible. And so you can actually write your own kind of build instructions as files, like a make file. If you put make files, syshappens here, we make files before. And it's called a bake file, of course. when you're making these images. So we like Docker build X bake there, and then it will actually just read that template out, and you'll be able to build in the way that you want to for the target locations and platforms that you're targeting. So it's pretty the DockerCon keynote demo was always kind of cheesy, like intentionally cheesy, bordering on uncomfortable, but worthwhile. Yeah, and now it's like, okay, I'm really going to mess with your heads now. Docker itself, the daemon, runs as a container. So now we want to upgrade from this version to the next version, we are simply stopping and starting that container again. So it's really nice. Upgrades are much easier, much more trivial. Moving from free version to EE, also very trivial. And then looking ahead, there's one talk by, you should go and check out, by someone called Michael Crosby. Now Michael Crosby, you've probably never heard of the guy. He's been like the core maintainer, he's like 27, 28 years old. He's been the core maintainer of Docker since 2013. It's like the guy, and you watch him speak, he's really like, you can hear the nerves in his voice. He's an absolute demon. Like he can, he's been right in the middle of this thing since the beginning. And so what he's working on right now is this whole idea of live migration. So much harder to do with containers than with virtual machines. But the idea being that we actually want to be able to transfer the state of a running container to another engine and continue running there. And that would have implications for stories when that happens too. But yeah, the idea being that we actually take the image over there, we take the file handles, we freeze the processes, ship the state. So very much kind of vMotion, if you like, for containers. That's what we're kind of working on now for many of the same use cases. And so a lot of that work is quite far advanced already as well. But it's a hard problem, it's a difficult problem to solve. Especially when you want to take networking and stuff with it. It's very, very difficult. Cool, all right. Okay, wow. So what now? Okay, so that was just a ton of information. It was kind of, honestly, a little all over the place because there's just so much info out there about this stuff. I honestly didn't really know what all of you wanted to hear. But it's just a bit of a brain dump from some of the cool stuff I saw from the last couple of days. Okay, what can you do now? Number one, beta.docker.com, if you like kicking tires on beta container products. We'd like people to do that, to talk to us about it. But it's the way that you can lay your hands on enterprise desktop, for example. The videos are up now. They were being uploaded this afternoon when I was on the train. You see them appearing. They are now published here. You can go and watch them. And I really recommend some of them in particular. If you're into the container biz in depth, the open source summit where it goes into each of those individual components. Each of those are like 9-hour-long talks that break down each of the things I was talking about. But also, our friend and colleague Oliver has just come back, and he just did a really good one on building a container pipeline, which actually solves this in a kind of very generic. He talks about it, he uses obviously EE to demo it, but it is really, he does it with Laura Frank, who works at Couchbase, Jenkins, company behind Jenkins. And does just a really good job of describing some really nice best practices around doing your software delivery pipeline with containers. And others like Dockerfile best practices. If you're in that business, it's just one of those. Especially if you're just picking up Docker, or if you just want to revisit some stuff, that's a good one. EE trials, if you want to do it, they are available to anyone with a Docker Hub account. So you can just get one by going to Docker. And if you want any help with it, you can reach me or the team in London. We'll be at KubeCon. Is anyone going to go to KubeCon? Would anyone like to go to KubeCon? Go to Barcelona in a couple of weeks' time? End of May? Sounds alright, doesn't it? Yeah, I'm sorry we just got t-shirts to give out today. No plans to do. And yeah, DockerCon 2020 will be in Austin, Texas. So only one, we're going to do 2 this year, or 2 in the last 6 months, but I'm doing just 1 next year. There will be road shows towards the second half of the year.
Yeah, so we're going to be running in the UK, which I'm really excited about. Sorry, you won't be able to fly to Barcelona, but...
Yeah, so in lieu of having, instead of having, because you probably have often, is that there's just the events calendar. And so people are just very choosy, and so they'll go to VMworld or Kubernetes or whatever, and then that's it, they're done. So what we're doing instead now, we're kind of bringing it to people in Europe. So we're going to do 2 maybe?
Yeah.
One in maybe Edinburgh or something? We don't know. In fact, I know what I'm doing in Germany, and I know what I'm doing, I know France, but anyway, we're going to go across Europe doing this stuff. But it'll be a mix of obviously all the enterprise goodness, but there'll be some community guest speakers as well, and we'll be trying to bring it to all of you in a similar way. So look out for that. What about Miss Jackie?
I was just going to say, if you haven't got a Docker t-shirt, please help us out. And I've set the task, wear your Docker t-shirt on this tomorrow, get some photos. But we've got a sign-up sheet at the back, so all the kind of latest updates, if you've missed any of that, then I can send the slides and links and everything to you. But also, I'd love to invite you all to the UK event that we'll be hosting this year. So please do just pop your email address down, and then I'll make sure you're added to that.
Yeah, and we're going to stick around for a little bit, aren't we?
Yeah.
Just a bit. And so if there's anything that I didn't talk about, that you do care about Docker, there's probably a ton of information that we can get in front of you as well. So just feel free to ask questions now, or in a minute we're going to begin. Would anyone like to ask a question now about anything I've spoken about?
Just the app converter, when you talked about app converter for legacy apps, how you migrate them. So how far we are in terms of that basically? Because you've got lots of legacy applications.
Yes. Yeah, so what it'll do, it'll detect, it's got like, I think they're literally called detectors for Tomcat, WebSphere, WebLogic, and IIS.NET and ASP. So it knows how to look for those middlewares, going back to some versions, and it will work on older generations of operating systems. So Windows Server back to 2003, I think, and like you can run it on like RHEL 5 if you've got some old apps, right? And we basically are working in order of customer demand for adding other ones. And if it's built on an open source framework, you're probably laughing anyway. So it might even be quicker to, rather than take it as is, to actually just to move it across to a more modern stack. The issues that we run into, so it's like it's going to get you most of the way there for many apps. I think the issues that we run into are often non-technical, because it will be like, this app is from 2009 and it's an HR app from a company that's gone bust and whatever, So we put this in a container and it's great, we can go and run it anywhere now, but there might be a concern about support or something like that. So it's sometimes non-technical reasons that get in the way. So you kind of got the stuff that can be containerized, and then the stuff that's you really should be containerizing. And that's a business decision. It comes down to like what benefit do I get back from doing this in terms of like actually exiting this data center or saving data center footprint because it's running more cheaply on less hardware and stuff like that. That's often the judgment call. But we've got some like known absolute green lights. Those are largely ones satisfied by like enterprise middleware. And then there's kind of amber, and then there's just some like absolute non-starters. To be totally honest, like we do get. I mean, it's we market it as like modernized legacy applications, and we do, right? But we do get like I've just gone through my basement and I've found this thing on cassette. What can we do with that? Can we do can we do COBOL? No. Hello, can we do no. We do that quite a lot. We do it quite a lot. But yeah, so basically with those no middlewares, you're golden, and that is an expanding amount anyway. If that helps. Yes.
So you mentioned a while ago about, I think it was Docker applications. So the issue that we sometimes have is when you're writing code on your machine, you'll have say a bunch of services, a database and a cache, all stood up in a compose file, and then when you want to actually deploy it onto a cluster, it's a separate file, which the two might not actually match up properly. And then when you want to deploy it to a different, let's say from test to pre-prod or something, we effectively end up using set to just replace bits of that YAML file.
Yes.
Does this Docker applications get around all that and allow you to translate compose into YAML?
Yes. It basically, you have one kind of descriptor, a container of containers, which is a terrible phrase, but it's what they're using. And you can churn out from that. There's actually a Docker app command, you know, the CLI plugin, like Docker app will churn out cube, compose, Docker swarm, and helm. So, but you can say which context you're about to use it in. So, if you want certain environment variables or certain resource limits or whatever in one environment or another, you can just summon those as it creates it.
And is that out now, is it?
Yes, cloud-native application bundles are the work and the standard of that is completely out there already. So we are our work. We announced it last December. I think it last DockerCon. The Docker app stuff should be in Docker for Mac and Docker for Windows today.
Great.
I think. And that's just an implementation of the cloud-native application bundle spec. So the spec is like not our property, it's everyone's property. And Docker app stuff is open source even, so it's everyone's property as well, but that is our implementation of that standard.
Cool. Thanks.
Any more? Alright, well thanks for listening, and that's a beer.